As we've talked about previously, solutions are composed of solvents and solutes. When the solvent is water, we consider this an aqueous solution, aqueous, an aqueous solution. In aqueous solutions, water is the solvent. So when we think about chemical reactions that happen under aqueous conditions, it's important to understand that water is the solvent. Okay, so practically what this means is that if you have a container, right, this container has a bunch of water molecules, and it also has other molecules, other solute molecules, distributed throughout the water. So as you'll learn in other classes, we think about the interactions between water and these solute molecules, and that we can explain how these dissolving reactions happen, right? So why the solutes actually dissolve in water because of the forces that hold the solute in close proximity with water molecules. When we're thinking about ions dissolving in water, so here again is our water, right? We know that water is distributed throughout this as the solvent, and when we drop an ionic compound into this water, right? So let's say we have an ionic compound, it's composed of cations and it's composed of anions. Okay, so as a solid, before we put this in water, the cations and anions are compacted together in close proximity. Right? So think about table salt. Once table salt is added to water, we know that we can no longer see the salt, and that's because the ions break apart and interact favorably with water. Okay, so the ionic compound actually breaks apart and we end up with ions separated in solution. Okay, so we can show this in a chemical reaction as something like sodium chloride, which is a solid ionic compound reacting to become a sodium cation and a chloride anion. This happens in water. Okay, so when we say aqueous sodium chloride, so we put AQ here, aqueous sodium chloride means that the sodium chloride has been dissolved in water, and when that happens, the ions separate into cations and anions. The reason I'm bringing this up is that we can actually calculate the concentration of individual ions in water. If, for example, we had 1 molar sodium chloride, we know this means 1 mole of sodium chloride per liter. Okay? If our goal were to figure out what's the concentration of sodium cations in this solution, okay, we can use the definition of molarity to figure this out. So right now we know it's 1 mole of sodium chloride dissolved in 1 liter. What we want to know is how many moles of sodium are dissolved in 1 liter. So if we're able to cancel out moles of sodium chloride in this molarity definition and replace it with moles of sodium, then we're actually able to figure out the concentration of sodium cations. Right? So if we could cancel out moles of sodium chloride, we'd be left with moles of sodium per liter, which is the concentration of sodium. Okay, so when we look at sodium chloride, we recognize here that for every 1 compound, we only have a single sodium atom. So for 1 mole of sodium chloride, we have 1 mole of sodium. Consequently, this ends up being 1 mole of sodium per liter, so the concentration of sodium would also be 1 molar. Let's see another example. If we have 0.5 molar magnesium chloride, okay, let's figure out two things. Let's figure out the concentration of magnesium in solution, and let's also figure out the concentration of chloride. We'll do magnesium first. We have 0.5 moles of magnesium chloride per liter, and I see in my formula here that I only have 1 mole of magnesium for 1 magnesium chloride, right? There's a 1 that's implied there. So for every 1 mole of magnesium chloride, we have 1 mole of magnesium. So the moles of magnesium chloride cancel out, and I'm left with 0.5 moles of magnesium per liter, or 0.5 molar magnesium. We can use a very similar approach for chloride. I have 0.5 moles of magnesium chloride per liter. I want to cancel out moles of magnesium chloride and be left with moles of chloride. Now in this case, for every 1 molecule of magnesium chloride, I have 2 chloride anions. So 1 magnesium chloride contains 2 chlorides. So moles of magnesium chloride cancel, and I'm left with 0.5 times 2, so I actually have 1.0 molar chloride. There's twice as much chloride as there is magnesium because there's 2 molecules of chlorine for every 1 molecule of magnesium.